So this afternoon I'm going to be talking about common ASP.NET design patterns. I will admit to you that I pretty much just threw ASP.NET into this title, and this is a talk that I've given before on design patterns that I've found to be useful. Most of my application development in the last few years has been in the web space and with ASP.NET in particular, so it wasn't a big stretch for me to adapt these to ASP.NET. We're not going to talk about every design pattern. We're going to focus on just a few, and we're going to talk a little bit about design patterns in general, how we learn about them, how we tend to use them once we learn about them, and I do hope that you'll find this useful. So a little bit about myself. Here's what I look like. You can find out more about me on about.me/Stephen A. Smith. And at the moment I work for Telerik after recently selling one of my businesses to them, and I'm running their services division with my wife Michelle. So that's me. Now let's talk a little bit about design patterns. Design patterns tend to be general, reusable solutions to common problems. The thing about the pattern is that it sort of sets up a recipe for how you're going to be able to approach the problem. It doesn't give you some code that you can reuse directly. It's not a complete finished solution, but it's sort of a template that is a pattern that you can follow that'll usually fit in a certain context. Now, we give each one of these patterns a name so that we're able to discuss these common design elements using a common vocabulary with our peers. So if you and I are having a conversation and you're describing a problem that you're having with, you've got this dependency or you've got this code that isn't very elegant because you're not sure it uses the right abstraction, I can look at that and I can suggest to you, well, have you tried using the such and such pattern for that? And assuming that you're familiar with that pattern, I can express a whole lot of conceptual intent in that one word without having to go to a whiteboard and draw UML diagrams for 5 minutes and explain how everything interrelates and drawing out the actual structure that the pattern in its name describes in and of itself. Now, when we talk about learning design patterns, I've found that you kind of go through certain stages. And I'm not a musician myself, but I have some friends I've talked to about this that are musicians. They agree this tends to be frequent for learning many different things, not just programming or design patterns. I do practice karate, and I've found that when you learn a new martial arts technique, you tend to want to use it more and more as you're trying to get better at it. So these are sort of the stages of learning that I've seen myself go through with design patterns, and I think you may find that this is true for yourself as well, so I thought I would share it. I've come up with these names and labels myself. There's probably some academic somewhere that's done a dissertation on this that has better names for these, but here's what I've come up with. So at stage 0, this is basically ignorance. So we'd apply this to any given pattern. So let's say that as of right now, you've never heard of the facade pattern. So you would have been at stage 0 until just now when I said the facade pattern, and now you've heard of it. So you're no longer at stage 0 for that pattern. The next stage that you would want to try and get to is what I call awakening. And so awakening is basically where you've got an interest in it. You've heard some more about it. Maybe you're thinking, wow, I just learned how the XYZ pattern can improve my design. I'm not really sure where it would work in my code, but I'm definitely looking for opportunities where I could plug it in somewhere. And so I've spent a lot of time in these areas for a lot of design patterns. I'm certainly not going to say I'm an expert at all of them or anything like that. In fact, the next stage is one where I tend to spend a lot of time, and that's called overzealous. And in the overzealous stage, that's where I totally get this design pattern. I'm adding it everywhere I possibly can in my code. My code's going to be so awesome because it's going to have this pattern in it everywhere. Everybody's going to think my design is awesome for sure now. And so you get into this stage where you know it and you found it to be useful in a certain situation, and so you think that maybe you could apply it everywhere. A few years back when XML first came out, everybody was overzealous about XML, and it was like, oh my god, we need to use XML for everything. More recently, there's other things like currently the repository pattern. Some people are thinking it falls into this category where people are using it for everything when maybe they don't need to. So watch out when you are learning these patterns. Be aware that your favorite one might turn into your golden hammer, where now that you know how to use this particular tool, everything suddenly looks like a nail. So what you want to strive to get to the stage of, for things that you're really going to use professionally every day, is the last stage here that I call mastery. And once you've mastered a particular technique or tool or design pattern in this case, the ability to use it is just sort of second nature. You've got this muscle memory developed where when you see the context that's appropriate to apply this pattern, you're able to just plug it in without really thinking about it, and it's just obvious to you that that was the right thing to do, and you can move right on, and it's a simple refactoring at that point. It's not something you're spending a lot of time even thinking about. So you're not going to get to mastery of every design pattern. I can tell you that right now, because there's no catalog of every design pattern. So tomorrow someone might invent a new one. You're not a master of it. But it is worth your while to pick a few that you think are particularly interesting and worthwhile in the kind of work that you do, and try and get to at least the overzealous stage of them, and hopefully to master them. And so I want to share here just a few of the ones that I've found to be most useful. All right, now in terms of the language benefits of design patterns, they provide a nice placeholder when we're talking for a very complex abstraction or a set of refactorings. So consider the difference between a conversation that might say, we have some tight coupling to the database here. We can probably fix it if we apply these refactorings. First, you need to extract an interface. Then you need to extract a method. Then extract a class. Then replace the local with parameter. That would be one way to say it. Another one would be, let's apply the repository pattern to fix this issue. And obviously the second one, assuming that everybody understands what that means, is going to be a much simpler and clearer way to express the intent when you're having a conversation. So I don't want to emphasize too little the value that these patterns have in terms of their naming, and that they have a common set of names that we all agree on as a profession to use when we refer to them. Speaking of named patterns, this is a comic from geekandpoke.com or .typepad.com. The URL's at the bottom. So I see you've used the very famous design pattern here, the steaming pile of crap pattern. That's right. So this is kind of playing at the fact that design patterns a few years ago had a lot of hype. There were a lot of books being published at the time. There's not quite as many of them now, although you do see people like me still talking about them. But they're still very useful, even if they're not getting as much attention as they were a few years ago. Now, a little while ago, it was about a year ago, I did a survey on Twitter, and this went out to about 400 respondents, and I asked them, of all of these design patterns, which most describes your familiarity with them. And the key is down here on the bottom right. So the red would be, what's that? Blue would be, not sure, have not used it, occasionally used it, regularly used it, and daily use. And so looking at this, it's not immediately obvious which ones are the most popular. You can see that some people only filled in the first couple and then quit. So the total number of responses for the last one is less than the total for the first one. But that doesn't mean it's less popular. It just means people got lazy and didn't finish the survey. So what I did is I sort of drew a line here and said, well, where is the point at which the have not used block is most off to the left of this line. And so once I did that, I was able to kind of grab the ones that are at least occasionally on this line, and those are sort of the most popular. And so these are the ones that most of the respondents at least occasionally used. It's obviously not the most scientific survey, but this gives you some idea of the ones listed here, which ones are the most popular. This would give us sort of a top 10 of patterns. Turns out that 10 design patterns is more than you really want to talk about in a hour to 75-minute long talk. So we're not going to do quite that many. Here's the URL to the poll. It's a twit poll, so if you want to look at the actual results, you can. This will be in the recording afterward. So here's the patterns that I want to talk about. We've narrowed it down to actually a top 6, 5 good patterns, and one I'm going to call it an anti-pattern. And so the singleton, the strategy, the repository, the proxy, the command, and the factory are the most useful patterns that I've found in working with ASP.NET applications. So let's talk about each of these. Of course, there are many others we're not gonna refer to in this talk. The first one, of course, is the singleton, which if you've ever seen the Highlander, you know that the Highlander, there can be only one. That pretty well describes the intent of the singleton design pattern. Now, the way the singleton is implemented is essentially that a certain class needs to only ever have one instance within an application. And the way that we're going to achieve that is we're going to make the class itself responsible for keeping track of its sole instance. And so that's the most obvious, probably one of the simplest design patterns that there is the singleton. And so, of course, there can be only one of it. Now let's talk a little bit about singleton and why it doesn't make my list of good design patterns for ASP.NET or anywhere else. Here's the sort of naive implementation of singleton. It's probably familiar to most of you. If you've done any implementations yourself or read any books, this is frequently sort of the implementation that's proposed. So we've got a singleton. Any particular class that we want to make a singleton, we don't have to name it that. We give it a private static instance of itself that we'll probably call instance. We make its constructor private so nobody can new this thing up. And we make it so the only way we can new it up is through this property, which typically is called instance. And we give it a getter that says, well, if we don't already have an instance variable, let's create one, and then we'll return that instance. Looks good? So this works reasonably well in a single-threaded environment. But the problem is that it's not thread safe. And so the issue here is that you might end up with multiple threads inside this if block, having both reached that point when the instance was null, and then each of them will execute the instance equals new singleton. Only one of them will ultimately end up setting this instance. But if it is in fact important that you not run this constructor twice, this will be a problem for you. Now the way you use a singleton is pretty much like you would use a class. You can just say, singleton.instance, call methods on it, sort of like a static method almost. You can assign a variable to that instance. So even though there's actually only one singleton, it doesn't mean you still can't assign it to something else and do things with it. And lastly, you can just pass it around as a parameter here. So anything that takes in that type, you can throw in the singleton instead if you wish. Just pass in the instance. Now here's an example of how you would do a singleton in such a way that it was both thread safe and fast. This is actually something John Skeet has written a fair bit about, and this code is taken from an article that he wrote, the source of which is down here. And this is obviously the most intuitive way that any of us would implement singleton with our knowledge of C#. We would immediately jump to the idea that we need a private nested class that happens to have a static constructor that has an internal static read-only instance that gets newed up immediately when it's called. Because this is just the way C# happens to work internally, means that this will be both thread safe and also very fast. It won't actually instantiate this class until the point in time at which this getter is called and we need this instance. So if you do in fact need to use singletons for some reason, this is the way you should be doing it. But I would argue that there are better ways to do it than to make the class itself responsible for its lifetime, which is basically what the singleton pattern is all about. So some of the consequences of using singleton are that it violates the single responsibility principle, and also the default implementation is not thread safe. So in a web environment like ASP.NET, you don't want to be using the default implementation, the sort of naive implementation. You end up with some tight coupling when you use this between collaborating classes, because you're referring directly to an instance type. You're not using any sort of abstraction. Singletons are difficult to test because each test is going to run and hit the same shared state. So just like statics and any other global state, these can be difficult to test. Someone's got their mic on. Turn it off, please. I mentioned it violates the single responsibility principle because whatever that class does, it's now responsible for managing its instances as well as doing whatever real work it has. And the thing I would replace it with is if you're using some kind of an IOC container or any other form of lifetime management for your objects, that's the better place to manage your object's lifetime as opposed to doing it in the class itself. Now, it's worth noting that I do work for Telerik, and Telerik has a tool called JustMock that you can use to mock and test singletons. There are other tools out there that are commercial tools that will also do this, but why would you intentionally write code that now you can only test with certain premium tools? That just makes no sense at all if there are easy ways to avoid doing that. So again, I would avoid using the singleton if you don't have to. All right, so if there's questions about that, I'll catch them at the end. So the next pattern I want to talk about is the strategy pattern. The strategy pattern is definitely one of my favorites. Stratego, which is shown here, is actually one of my favorite games when I was growing up. The intent of the strategy pattern is to encapsulate a family of related algorithms, which sounds very theoretical and mathematical there. The nice thing about using the strategy pattern is that the algorithm can vary independently from the classes that use it. This makes it a very popular pattern for achieving a couple of solid object-oriented design principles, specifically the single responsibility principle and the open-closed principle, both of which relate to being able to change a class without having to actually recompile it, is the open-closed principle, and removing dependencies and responsibilities from a class and putting them somewhere else, which is the single responsibility principle. So you'll see this used quite a bit. As I mentioned, this is one of my favorite patterns. I'm probably in the overuse category of stages of learning this pattern, but I do use it constantly. If we look at the structure for this design pattern, this is the UML. Would love it if some folks would mute their mics. Apologies for the fact that I can't do that myself easily from live meeting, at least not without keeping that open the whole time. So with strategy, you're going to have your context, which is the class that needs to do something. And you want that something to be variable, and you want that something to be not a dependency of that class that is tightly coupled. You want to be able to break that dependency, for instance, when you want to write tests. And so what you'll do is you'll extract the actual thing that the context is calling into an interface. And the interface should be ideally defined on the basis of what the context needs. So instead of looking at your concrete thing and looking at all the methods it has and creating an interface from that, you're better off to look at the methods that your class that's doing something with that object is actually calling, and created a very fine-grained interface that has just the things that that thing needs. And then you're going to create the actual strategy that does the work, which is going to implement that interface. And you can create more than one of these. Now, it's not uncommon in your production code that you're going to create just one of these. But the value of having that interface is that you're keeping things loosely coupled, and you're making it so that now in your tests, you'll be able to mock or fake those dependencies so that you're able to test your business logic without getting mired down in infrastructure code. And it also makes it so that when you do have new features or new ways of doing things that you want to add to your system, you can do that by writing new classes and replacing the implementation of the strategy that you're using rather than changing the code that you already wrote. And the nice thing about writing new classes is nothing in your system depends on them yet. So whenever you have an opportunity to write a brand new class, you should try and strive to do that instead of changing existing code, because you're much less likely to introduce regression bugs, because you know that you're not affecting anything that's currently in the system, because nothing new about your class until you just wrote it. So in terms of common usage, for the strategy pattern, you'll see it frequently used for dependency inversion and dependency injection, and I'll show you those topics in just a moment. You also will see it used to decouple class dependencies and responsibilities, pretty much by using dependency inversion and dependency injection. It's nice, the strategy to use the strategy pattern is to create an interface for each responsibility that you have, and then create an implementation of that responsibility that implements that interface, and pass that in through the constructor. And then you can simply move the implementation out to a new class that implements that interface. And we'll see how that works in just a moment. If you saw my other talk this morning, I covered some of the same stuff there as well. Now, this is not really related to design patterns per se, but it is something that I've been talking about for some time and I'm passionate about. And this is that you should avoid having classes that have hidden dependencies. You don't want your code to be lying to you, the programmer, or to the other classes it works with. So in my opinion, ideally, you want your classes to declare anything they depend on in their constructor. And what this does is it makes it so that anytime you are able to create an instance of a class, you know that that class has the things it needs to do its job. And somebody else has their mic on. So the way you avoid hidden dependencies is by making sure that this class doesn't need anything that isn't passed into its constructor. So if you have a class that, somewhere in the body of some method somewhere, it's newing up a connection to the database and inserting something, but there's nothing in the constructor that says anything about needing a database, that's a hidden dependency. If there's some static method that shoots off an email and the class won't work unless there's an SMTP server because it'll just bomb out with an SMTP exception, that's a hidden dependency. That should be in the constructor. And what you'll find is if you write classes that always expose their dependencies in their constructors, you'll have a much better factored system where things are more loosely coupled, and it's very easy for you to look at a class and say, okay, I know exactly what this needs. I can test it. I can when I put it into production, I know the things that it needs to have in order to work correctly. So to follow this advice, you should avoid making non-stateless static calls. It's perfectly okay for you to make a static call that adds two numbers together and gives you back the result. A lot of extension methods are like this, but you want to avoid the ones that call into some kind of infrastructure and talk to a file system or a network call or a database. Those are going to cause you problems. You also want to avoid directly instantiating classes if you can, specifically like services and business level classes that do real work. Instead, you want to move these things to an interface and then use the strategy pattern to inject them. In that regards, you should consider the new keyword to be basically glue in your code. And so the reason why I say this is because it's going to create tight coupling between your classes, just as if you were writing static calls or implementing singletons between your class and its collaborators. So it's not to say that you should never instantiate anything in your application, because obviously somewhere you're going to have to decide the actual implementation and instantiate it. But you want to be careful where you do that. If you bury references to new deep inside of all of your implementation code, it's going to give you a very tightly coupled system that's difficult to test. So just be conscious of the consequences of using new, and any place that you find that you need to loosen up the coupling, use the strategy pattern and swap out that new keyword with an interface that you inject through the constructor. All right, so let me take 1 second to grab a drink and check any questions that we have coming up. Doesn't look like much. And there's questions on Q&A. Oh, there's 4 of them. Do I see them? Yes. Are there any localization frameworks taking advantage of Google? That's not my question, that's earlier. All right. What design patterns are covered here? I think we've gotten through that at this point. Injecting implementations via constructor, we can do it via properties. What would be the best approach and why? There's pros and cons to both. I just explained why I prefer constructors, because I think that makes sure that you can't get an instance of that class that doesn't have its necessary collaborators and dependencies. If you use the property injector method, which is perfectly valid, the problem with that is that you have now a 2-step process where you have to create the thing and then you have to set the properties. And there's nothing in the language that prevents you from creating it without setting the properties or without setting all the properties. And so you might end up with an object that's in an invalid state. So I prefer constructor injection anytime you can get it. Could you put the presentation for download? Yes, it'll be on my blog. It'll also probably be on aspconf.net. Look for it on ardallas.com. And can you talk a little bit about Memento? Maybe. I know there's a talk about Memento on Pluralsight in their design patterns library, so you may find it there if I don't have a chance to talk about it. I know I don't have any demos or anything ready to go for Memento today. Can we see an example? Yes, we'll definitely see examples of strategy pattern. An example of bad versus good in good would be good. I have no idea what that means, Rob. Sorry. All right. You have 3 seconds to fix it. Nope. All right. I'll catch you later. All right. So next we're going to talk about the repository pattern. As I mentioned, the repository pattern is very popular these days. Some are saying it's being overused. If you're not familiar with it, it is a data access pattern, and its job is to separate out the responsibility of persistence from your business classes and from your user interface and everything else. So it wants to take the concern of persistence and wrap it up in a collection of interfaces and implementations that are separated from the rest of your application. When you do this, this enables you to follow the single responsibility principle, because now your controller in your MVC project doesn't need to know how to persist something. Your page load or your click events in your ASP.NET Web Forms project, they don't need to know about persistence. Your business classes don't have to know about persistence. I'm not a fan of business objects that know, for instance, how to get themselves out of the database and persist themselves back to the database. I've done that before on multiple projects, and it's always ended up in pain for me. Whereas the repository pattern makes it so I have a much more testable solution that has very good separation of concerns. Frequently, when you go down this path, it's common to have an interface for any given entity that you're working with. For instance, if you have a store, you might have customers and orders and products. You might have a repository for each of those. It's also very common to implement a generic interface, like an iRepository of T, and give it some common methods that all of these types will share. For instance, a get and a list and an update and a delete and a create. And so once you do something like that, especially if you're using an ORM tool like in Hibernate or Entity Framework or what have you, you can then create a generic implementation of that generic interface that does everything for most of the entities without you having to write a lot of code. And you can just, anywhere you need a repository of customer, you just create a new instance of iRepository customer, and it automatically wires up your generic implementation repository of customer that knows about the basic operations. And when you need more than the basic operations, that's when you can extend that class to do the specific thing that you need. Now let's talk a little bit about data access and where data access I see tends to evolve. So in terms of evolution, when you first start out with a simple application or you first start out with learning how to program, you tend to, in my experience, write code that's pretty simple, and you've got no separation of concerns, and you've got your data source or your data access code kind of just commingled right in with your user interface and your business logic. So maybe you're using a ASP.NET data source control that came out in 2005. If you're going all the way back to like classic ASP scripting, you've got your record sets and your HTML all mingled together in the same script. You might be doing it with the code behind, but that's still in the UI layer. So in your page load, you might be newing up a ADO.NET data connection or calling out to Entity Framework. In your button click, you might be doing the same thing and saving it. And so your code looks something like this. You've got a single layer, which is your user interface, and you've got a database. And at compile time, which is the blue arrow, you're talking directly to it. You're hard coding all your calls to ADO.NET or some representation of the database schema through an ORM of some sort. And there's no abstraction here. There's no interface involved. There's nothing that's going to change the fact that when you click that button, it calls that code. And so at runtime, the arrows follow the exact same path as they do at compile time. Now you can evolve this a bit, and you can add stuff like helper classes, and this will dry up your design. Dry meaning don't repeat yourself. So you'll get rid of the fact that maybe 15 different places in your code you were newing up an ADO.NET connection, and you figured out, hey, I could put that in a helper class and do it in just one place. And so now you make all your data calls through a utility, and maybe you use a tool like the data access application block that I used for years with their SQL helper tool. Your logic is likely to still live in the user interface layer. And so now things are going to look kind of like this, where you've basically introduced these helper classes. Everything goes from the user interface straight through the helper class and still to the database. But you're still seeing that your compile time and your runtime are following the same path, and they're both tightly coupled now to the database. You might have a user or a business logic layer in here, but it's still just calling through a data access layer or a helper layer, and ultimately everything's depending on the database. So the missing piece here, in this case, is that there's no easy way to abstract the data. And this results in tight coupling. It leads to these big ball of mud type systems. And so the solution is that you want to introduce these interfaces, and that's where the repository pattern comes in, is because when we start introducing interfaces specifically for persistence, we simply call those repositories, right? That's the thing. It's the intent of those interfaces is to abstract away the persistence issues for us, and when we do that, we call that pattern the repository pattern. And so now, when you write your code, you can have your user interface at compile time talk to an interface, like the iFoo repository. But at runtime, it's actually going to run the SQL foo repository to talk to the database, or the entity framework foo repository, or what have you. This gives you loose coupling because now we can swap out that infrastructure code, or we can replace it with a fake implementation or a mock, and make it so that we've got more flexible code. All right, so that's the repository. There's my nice visual for that. And here's an example. If we look at, for instance, the MVC Music Store code that I'm going to jump to here in a second for a little bit of walking through the code, in the home controller for that application, the code looks something like this. This is the entire home controller. And so this is the lack of a repository here. So we've got now this is entity framework. This is our data access layer. We're newing it up right here in the controller, and then we're calling it inside this little helper method, this get top selling albums. We just take storedb, and we're querying it with some link code here, grabbing a list and throwing that into the view. Now, if we wanted to test this, we would be hard pressed to do so, because anytime we run this controller, anytime we instantiate it, it immediately news up this music store entities, which is an entity framework DB context, which immediately tries to talk to the database, and if you don't have a database, it's going to blow up. So it's difficult for you to unit test this code as it stands now. So if we want to use both the strategy pattern and the repository pattern, we would do something like this. We would look at that code that we were calling, and we would say, you know what, the thing that I really need is a get top selling albums method. So I'm going to create an iAlbum repository interface with a get top selling albums method on it, and we'll pass in how many of them I want. And then I'm going to implement that. So I'm going to take the exact code that I had in my controller, this code here that gives me that entities, and this code here that does the return with the link. I'm just going to copy and paste it into an implementation of this interface. So now I've got an entity framework album repository that implements the iAlbum repository. And then back to my controller, which you can see is much shorter now. All I have to do is use that interface, use a local implementation of that interface, which is right here, this private read-only field _ album repository. That's what I'm going to actually use in my code. So if you look at my index method, you see there's no new in here. In fact, if you look at the entire controller, there's no new in here. I'm not instantiating anything in this entire class now. I'm also not calling any static methods. So this is obviously a very simple controller. It only does one thing. But you can apply this to much more complex systems, and it will give you big benefits. You'll end up with a very lightweight controller that doesn't have any hard dependencies that'll be much easier for you to test. Now, if we're going to go down this repository path, one of the questions is, where should those repositories live? And so I'm a big fan of domain-driven design, domain-centric design for how you do your layering, implementing these interfaces. And so I like to put the interfaces and the abstractions inside of a project that I call core. And if I don't have a project called core, I'll create a folder called core inside my MVC project. And inside core, that's where you're going to have your model classes, most of your business logic. It should not have any dependencies. It definitely should not have dependencies on things like databases, network code, email, anything like that. It should be as clean as possible in terms of dependencies. Everything else in your system should depend on it. And the reason why we call it core is because there's a name for this architecture called the onion architecture that basically describes your system as a series of concentric circles, like a cross-section of an onion. And these are the things at the very center. And everything on the outside depends inward. So everything depends inward toward this core set of classes and interfaces. Next, put the implementation of your repositories in an infrastructure project and have that reference core. And then have your user interface typically reference both of these. It's going to be responsible for actually creating the object graph that it's going to use at runtime. And you can do this by hand. So, in your home controller, if you need to, you can new up the exact things you want to use in a secondary constructor, and I'll show you how to do that in a minute. Or you can use an IOC container like Structure Map or Unity or Ninject. And an IOC container, it stands for Inversion of Control Container, and it's a class or a tool whose job is simply to manage the lifetime of the objects that are used in your application. All right, so let me see, we got some more questions. Jump to those. Decorator pattern, maybe I'll talk about that. A bunch of them. All right, somebody's been cleaning these out. What is better, customer repository or customers repository? Well, I think that's going to be a matter of taste, but I prefer singular because it's easier to spell consistently. Can you clarify between repository and service pattern? Well, you can call anything a service, and so I use services for anything that I don't have a better name for. So repository I use mainly as a matter of intent. So that if you're looking at my Solution Explorer and you're looking for something that does persistence, you're going to look for the repositories. You're not going to look for the persistence service, just because repository carries that extra context in the name. Now, if I'm not answering your question correctly, I apologize. But that's there is no design pattern I'm aware of that's simply called service, so I'm not sure which one you're relating it to. Elaborate on decorator, probably not. What category does repository fall in? Structural, behavioral, or creational? That's a good question. It's not in the original Design Patterns book that uses those categories. It's actually comes in the DDD book or maybe the Fowler book. I can't remember which. But I would say it's probably behavioral. So we'll say that. From the face of it, it appeared to me that strategy and repository patterns seem similar. Well, I'm using them together, but they actually are very different. And you can use, I'll show you an example of how to do strategy that doesn't involve repository at all, if you like. Do you recommend using virtual method in repositories? There are reasons why you'll want to do that. The most important one being that if you're trying to override the things, when we get to the proxy pattern here next, that can be useful. For instance, if you're trying to do lazy instantiation or caching, that can be helpful. So I'll talk about that. The DDD book, sorry about that, that's Domain Driven Design by Eric Evans. And he talks about a lot of design patterns in there above and beyond the design patterns that are in the original book called Design Patterns. New example, use interface. How do you make sure the right class is called if the same interface is implemented by multiple classes? You have somewhere in your code, you're making a decision about which implementations to use, and it's that piece of code's job to make sure the right one's being used. And I'll show you that in a minute. You can do that manually and hard code it, or you can use an IOC container to do it. What type of object do you like to pass into create save methods of? It seems like you're passing models, and now your repository becomes tightly coupled to the model. Yes, I like to pass in models, and I like my repository to be tightly coupled to the model because the actual implementation of the repository is in the infrastructure project, and that project is already tightly coupled to the core because that's where all the interfaces live. So the interface of, whatever repository is in core, and so are all the model objects. So I would prefer for my repositories to give me back model objects and to work with model objects. If under the cores they're using some other type, like entities that are specific to the ORM that they happen to be using or something like that, or data tables or whatever, I want to keep those concerns inside my infrastructure project, not let them leak out. If I've got repositories passing back data readers or data tables, that's going to be a problem because now every word in my code I have to know about data readers and data tables instead of my actual domain objects. Which IOC live do you recommend? I like Structure Map. but there's not a whole lot of difference between a lot of them. So there's Unity, there's Ninject, Windsor. There's quite a few, but my personal preference is structure map. All right, so let me jump back to the code, and we'll talk a little bit about the proxy design pattern. So I had trouble coming up with a good, pretty image of what a proxy is. So the best I could come up with was this sort of cartoon here that kind of describes the proxy process, where the proxy is something that basically sits between two things and relays messages back and forth. And so the intent of the proxy design pattern is basically that it's a class that controls access to another class. And we've got somebody else on the mics that hopefully they'll mute at some point. Now, when we talk about controlling access, there's a few different ways that we can do this, and there's a few different reasons why we would do this. So you can implement it via a subclassing the class that we're controlling, or through delegation using a common interface. And it's also some use cases for proxy include remote proxy for web services or network calls. You can use it for lazy loading, which we'll talk about in a little bit, but specifically when we're talking about having repositories with virtual members, one reason why you might do that is so that you can overload those members with a lazy loading proxy or one that implements caching, either one. And then lastly, you can use it for security or access control. All right, so in terms of structure, the proxy structure here is using an interface. As I mentioned, you can also do it with direct inheritance. And looking at this, you can see that the actual UML looks an awful lot like strategy. So you'll find that some of the design patterns structurally look the same, but the difference is in their intent. So even though the UML for this pretty much looks the same as what I showed you for strategy, we're going to call this proxy not because it looks like this in the UML, but because of what it's doing. And in this case, what it's doing is this proxy implementation here is representing the real subject and controlling whether or not the real subject is getting to do anything. It may decide that the real subject only gets to get called if the user has the right credentials, or if the cache is invalid, it has to go back to get the real value from the real database. Things like that. All right, the lack of muting of microphones is really bugging me, as well as others, I'm sure. So if someone can fix that, that'd be great. All right, so a common thing that I have done very effectively with the combination of the proxy design pattern and the repository is to add caching to a repository. And so let me show you how this works, because I think it can add a lot of value. For anyone that knows me, I'm a big fan of caching. I've been doing stuff with caching for like the last 10 or 12 years with ASP.NET. And caching is frequently something that you add to ASP.NET applications because it gives you a huge performance win without really costing you anything if you've got data that doesn't change very frequently. And if you put in things like a SQL cache dependency, you can actually make it so that even when the data does change, your cache gets expired. So you're not really even paying a tax other than a little bit of memory for using caching. Now, it's very common when you write a data access layer or a repository to go in and tune it and say, you know what, this method isn't quite as quick as it could be, that data doesn't change, let's add some caching. And you just go right into that code and add some caching to it. And the problem with this is that now you're violating some principles like this single responsibility principle, where you've now coupled the data access logic and the caching logic in the same class. And it's going to be difficult for you to change one without touching this class or changing both. So since caching logic is a separate concern, it should live in a separate class from the main data access logic. But you don't want to have to hard code these links between all your data access classes and all your caching classes. So an easy way to make it so that they can communicate without you having to write any plumbing code is to implement this proxy pattern. And the proxy pattern gives you this really straightforward way to say, I'm going to have a proxy, which is my cached repository, and it's going to be the thing that my UI code actually talks to. And that cached repository isn't going to do any data access, but it's going to know whether or not the data in the cache is good enough to return. And if it is, then it'll just return that. And if it's not, well, then it's going to know about the real repository that actually knows how to get the data from the database, and it'll delegate the call to that real repository, fetch the data from the database, and then store it in the cache. So let's look at an example of this. So here is the iAlbum repository that I just showed you before, only I've implemented it now as a cached album repository that's going to use some HTTP runtime caching. And so you'll see that the cached album repository implements iAlbum repository, so it's got the same IEnumerable get top selling albums that we saw before, but in its constructor it's also taking in an iAlbum repository, which is the one that's going to do the real work. So this is an example of doing the proxy pattern, but following pretty much the same structure as the strategy pattern in terms of how we're determining which other class I'm proxying for. This is very flexible. Not entirely necessary. If I wanted to, I could just hard code an entity framework repository right here. It wouldn't be quite as flexible, but it would still work. Then in here, oops, sorry about that. Then in here I'm going to do all my caching logic. And so caching is not a trivial thing. It's easy to get it wrong. So you can imagine if I had to put in these 12 lines of code or something into every one of my methods in my repository that needed caching, that would get very old very quickly. And so this is all the logic that I need to do the caching correctly. And then right in here where it says result equals, that's where I'm going to actually call to get the result from the underlying album repository. And that's where I'm controlling access to that. I only ever get to that if my result from the cache is null when I go to fetch it. All right, so let's see. I'm about done with repository. Let's see what other questions we got. PowerPoint, it'll be up. Mute them in live meeting. I'm supposed to have a moderator doing that. It's fun. Mute all but me. Oh, that might have worked. Thank you. Why structure map over the others? I've used it more, and I have used in some systems. I've used Ninject where it wasn't as fast as structure map, and it mattered there. For most applications, it won't matter. So I wouldn't necessarily use performance as a reason. I have used Ninject on other systems, and it works just great. So no real reason other than that it's one I know. That did seem to help, Jeremy. Thank you. What type of object? I talked about that one already. Yep. Okay, good. I'm caught up. Of course, now you're all asking questions. All right. Can we use cache by annotations? I'm not sure what you mean by that. Is that like aspect-oriented programming or something else? How does this differ from decorator? It's also very similar to decorator. So yes, you're correct. The proxy, the decorator, and the strategy all actually look very similar in the UML. The reason why proxy is different from decorator is in its implementation and its intent. The decorator pattern's job is not so much to control access to something else, but to let you chain together some different behavior in an arbitrary order in order to apply multiple behaviors to one particular underlying object. And that's not at all what the intent of the proxy pattern is. All right, so we'll say that's good enough and jump on to the command. So we've got two left. We've got command and we got factory. So the command pattern here, I'm representing with an envelope in this image here. So this is the idea that we can package up something that we want to do, wrap it up in an envelope, and send it somewhere where it eventually will get implemented. And so this is very different from just directly calling some code, but it has a lot of benefits. So the intent of the command pattern is basically to represent an action as an object, and it allows us to decouple performing the action from the client that's actually issuing the command, which gives us some nice benefits. For instance, we can do some delayed execution. We can use this for some logging. We can have an audit trail of the actions that were taken, and then we can use that audit trail to enable undo type functionality, so that we can. Someone was asking about the memento pattern. That would be sort of an example where we have a series of commands that we keep mementos of, and then we can implement undo by basically knowing how to do the reverse of each of those commands and then popping them back off the stack to do the undo or revoke transaction functionality. One of the things that I find commands to be very useful for in ASP.NET applications, especially high performance apps, is to delegate things that can happen asynchronously. And so that's sort of the delayed execution scenario described here. In terms of the UML, it looks like this. I'm not going to spend a whole lot of time on it. But essentially, the client is going to create an instance of this command, and it's going to send it somewhere. And then that recipient is going to actually run the command. They're going to execute the command. One of the common usages that I've found for commands is in representing state transitions. So if you think about a web-based publishing site like codeproject.com, they have articles. And the articles might come, when you first create an article, it might be in draft status or pending status. And then when you're ready to publish it, now it's in published status. And maybe after a while you go through and you clean up some of the articles because they're old and no longer useful. You put them in an archive status. So those are states that your system might be in. It's very common to use commands to represent those state transitions. And so this is generally different than how most folks learned about object-oriented programming in like the early days, where at some point you probably were told, think about the problem that you have and describe it, and then pick out the words and use the verbs as your methods and the nouns as your objects and your classes. Well, that transition from pending to published that's represented by this arrow here, that's never a noun in your description of the problem, where you say, as a author, I want to be able to publish an article, right? You've got a publish verb there that you're going to probably make a method called publish. And the problem with that is that now when you want to unpublish it, you need a different method. And on both of those things probably live on article. And so now article needs to know about how to publish, how to unpublish, how to archive, how to go back to draft, how to, it's got all this logic that suddenly starts accumulating on it because it needs to know about all these state transitions, because we're identifying them as methods, not as their own objects. Command is great for breaking that, because you can say, you know what, I'm going to have a command that describes that transition for pending to published, and it knows about all the things that have to happen there. Oh, I've got to send a notification to the editor. I've got to update the article. I've got to decide that now I've got to copy it to the staging server so they can be viewed. These different workflow items that all happen in that particular state transition now can all live in that one class, and you can write tests for just that class without having to new up an article and then get it into the right state and then call that method and then mock out all of its dependencies and get that logic in one place. No, you've got it all in one class that does just those things, and it follows the single responsibility principle much better. The other place where commands are great, again, is in an e-commerce type of scenario where you're Ticketmaster and you're trying to sell a bazillion tickets for a new concert at 10 a.m. And you don't want to necessarily have every single one of these 10,000 users that are all hitting your site at 10 a.m. have every single one of those have to talk directly to your database to reserve the exact tickets they want, and then talk directly to your credit card processor to make sure you can charge the card right then. Instead, it's better for you if you can just have a command that is there. Another good example is Amazon. When I give this talk in person, I like to ask, has anybody here ever bought anything from Amazon? All the hands go up. So pretend that I just did that and you just did that. All right, so when you buy something from Amazon, and you click the checkout complete link, and they come to the thank you page, what does that look like? Does it say, here is exactly what you ordered. Here's your receipt. You ordered this book and that book and the other thing, and here's the total, and here's the tax, and here's how much it costs, and thank you for your order. No, it doesn't say any of that. It just says, thank you for your order. It doesn't give you any information. Now, eventually, later, you get an email, and the email says, hey, we got your order, and it had all this detail in it. But that was later. That's the deferred execution that I'm talking about, where Amazon is able to figure out that 99% of the time, whatever you ordered, that order is going to go through just fine. So I'm just going to send you a static thank you page that doesn't require any server resources for me to figure out, doesn't require any rights to the database or anything like that, and I'm going to defer the actual job of placing this order. I'm going to make a command out of that, and I'm going to put it on a message bus or something like that, and then something else, somewhere else other than on my web server, I'm going to actually go through and look at that, pop that off the queue, and execute that command to place your order. And it's not until that time that I'm going to check to see if your credit card is good. I'm going to check to see if these items are in stock. I'm going to do all those things that are kind of slow and don't necessarily help get the customer's transaction completed on the website so that they can move on with their day. Because the faster you can get through that checkout process, Amazon knows, the more likely you are to go ahead and just buy and not walk away. every second that they delay, they're losing business. So this is a great way that you can use commands as a way to package up things and delay their execution until another point in time. All right. Factory pattern. I'm going to go through this one really quick. The intent of the factory pattern is to separate object creation from the decision of which object to create. You can defer creation of these as well. Looks like the video is being slow, so you guys will catch up in a sec. There we go. So you can defer the creation, which is good, especially when you have expensive objects. You can also add new classes and functionality without breaking any client code. So you could make it so that only the factory needs to change to know about these new types. And if the rest of your code only knows about the factory and doesn't know about the actual implementations that the factory returns, you don't have to change any of those other classes. So you're following the open-closed principle at that point. There's a few different ways you can store this. So you could store it all in code, but you can also store it in configuration and some kind of persistent storage like the file system. You could just have a plugin folder that you drop assemblies into and the factory automatically picks those up. All those things work. If you think about IOC containers, they're basically just the factory pattern on steroids. Their job is to do all these things. They're gonna know about how to add classes. They're gonna decouple your application from knowing which objects are being instantiated, and they just perform this factory service for all the object creation in your code. Now, I'll show you some examples in just a minute, but one last thing I want to say is practice PDD, which is pain-driven development, and that means don't go in and try and apply all these patterns to your code from the get-go. Look at how you can build the simplest thing that works in your application, and then if it's causing pain, fix it. Look for ways that you can use these design patterns to make your code a little more flexible. All right, so we're going to do a quick code walkthrough. I'm going to show you some stuff in the MVC Music Store, and we'll go from there. So let's see. Commands. I'll get back to these. I can't see. Here we go. So MVC Music Store is available on Codeplex here, and if you look at the source code for it, under the forks, if you want to see my code, go into the forks and you'll find right here this MVC Music Store repository pattern by S. Smith. That's me. So I'll send links to that out with the presentation as well, so you won't have to go looking for it. But that's where you'll find it if you're impatient and you want it right now. If we look at their code, there's one bit I want to show you, and that is in the controller, in the checkout controller. Let's look at the code. I already showed you the home controller, but let's look at when you have address and payment. That's when you're checking out. So we're going to new up an order and do all this stuff here where we're going to save a bunch of things. We're going to save the order. We're going to process the order, and we redirect. So this is an example of sort of the naive way that you would do an e-commerce store, where all of the data access happens right in line when they click checkout. So if there's a problem with saving to the database, or where you don't have enough stock, or there's an exception, or whatever, we're trying to charge your card, which this isn't doing, obviously. Any one of those things will block your ability to check out. And those are bad. If you're trying to write a real e-commerce implementation, you don't want anything to block the user's ability to buy something from you. So we're going to come in here and look at these different patterns as they're applied to the MVC Music Store. And first off, we're going to talk about the home controller and the strategy pattern. And I showed you this in the slide, so I'm not going to spend much time on it. But we're going to pass in our implementation right here through the strategy pattern. Now, if you want, you can hard code, like this, the implementation that you're using. So I can go in and say, if I don't have an IOC container, I can still do all this stuff, but I need to hard code the implementation in my controller by creating a second constructor that takes no parameters and having it delegate to my parameterized constructor, passing in the things it needs. The challenge with this is that if I want to change it, I have to actually open up this code and change it. So if I come in here and I say, no, now I don't want to use the cached one, I want to use just the straight EF one, like this. I've got to go and I've got to do that, and then I've got to pick one of these to use. So that's how you can do what's called poor man's dependency injection. Everything else here is pretty much the same. So now if we look at my test for the home controller, the nice thing about doing that is that I can now use a mock of the iAlbum repository. I can say, when I call this thing, when I call get top selling albums, I want it to return this get test albums method, which is right here. Just gives me 5 albums. And then I can go in and I can assert that I have 5 items in my model that I get back when I call controller index. And I could do much more valuable things than this, right? I could assert that my model has the right things in it or whatever. But basically the goal of every controller is to give you the right view with the right stuff in the model. And so I can do things like assert that I got the right view by name and then I got the right stuff in my model. And that's all you want to be able to do with your unit tests on your controller. Jump back up to the infrastructure in this folder. The EF album repository, I showed you already. It's pretty simple. Notice I am using virtual here. That's because at one point my proxy implementation was inheriting from the EF album repository to do its work. But then I shifted to use a different one that I showed you in the slide. So here's my cached one that follows the proxy design pattern and passes these things in. For the command and factory, we'll look at 2 things. We've got the checkout controller. I just showed you the original way it was done. Here's how I would change it. So here's the original code. The new code would be create a command and a command processor or some kind of message queue. And both of these could be passed in through strategy pattern if you want. I'm just newing them up here for simplicity's sake. And then you queue up the order. And then that should do anything related to the order. So this processing here, that should not be necessary anymore because that would be done in the order processor once it ultimately gets the command. And so this does no work. It just puts the information about the order into some queue, and then you're able to continue immediately with the implementation of the code. And then the last bit is the factory pattern. A very important way to use the factory pattern is when you have an expensive bit of code that you want to be able to pass around without actually instantiating it. So by expensive, I mean the code itself is expensive to instantiate. And in this case, when I do my caching logic, I'm going to create a cache dependency right here. And so this cache dependency factory is responsible for that. Now, if I need a cache dependency, and let's say I pass that in as a parameter here, and I say I need to know what that is, or I pass it in even here, and I say anytime I new this up, I've got a dependency, I need this cache dependency, go ahead and give it to me. The problem with that is that every time you instantiate a SQL cache dependency in ASP.NET, it actually talks to the database, and it checks to see if the database table is set up for SQL cache dependencies. And so you'll end up with a huge performance hit rather than a performance gain when you do that. So the way you avoid that is you, instead of actually putting the dependency here, you put the way to create the dependency here. So this type that it's expecting is a cache dependency type, but instead of actually passing it one, I'm passing it a method that will create the thing just in time at that moment. And then I put that actual logic in here that can do this SQL cache dependency call, which is expensive and you don't want to do it except at that last moment when it's necessary. So then the last bit I want to show in the code here is how my IOC works. This is my inversion of control. This is using structure map. This is some different ways to set it up. Basically, structure map has this thing called with default conventions. That means anything called ifoo, if there's an instance around called foo and nothing else, it'll use that one. So as long as you use a naming convention where everything is I whatever and the implementation is called whatever, then this part here is all you need. But if you want to make decisions about what to use, you can do that like this. So you can say, anytime I have an iAlbum repository, I should use the EF album repository. Well, let's say I changed my mind and I want to implement caching. Well, then I can do this and say, okay, well now, anytime I want an iAlbum repository, I want to use the cached one. Well, if I only had that would be a challenge because the cached one needs one itself, right? So I'd get into this infinite loop where it would keep trying to instantiate a cached album repository to create a cached album repository. But I can fix that by saying the constructor is the entity framework one. Let's say I need a singleton. Well, the nice thing is I told you singleton is an anti-pattern in the class itself. If you have an IOC container, implementing singleton is just a matter of saying dot singleton. Bam, you're done. You don't have to worry about whether it's thread safe or anything else. You can assume that your container of choice has taken care of those issues and just do that anytime you need a singleton. All right, so I'm about out of time. If I have any time left, I'll talk about a quick tale from the real world. These are my references. Originally, somebody had asked about design pattern books, so here are several. This Headfirst Design Patterns one is one of the best learning ones. I do recommend Pluralsight. I've got a couple courses there on design patterns, on interior application design, solid principles. And I'll have the slides and stuff on my blog at ardallis.com, or you can follow me on Twitter as ardallis. So look for me there. To sum up here, design patterns are great to use as a guide when you're refactoring to get a better quality of code and a more elegant design. You should become comfortable with the ones that are most useful to you, but be at least knowledgeable of the other ones that exist so that you can carry on a conversation and not look stupid when somebody uses a word that you've never heard of. So at least, try and have some idea of what they are. Use them to address pain, but don't try and implement all of them everywhere up front, because that's just going to cause more complexity than it helps. And note that you can combine these patterns in powerful ways. So by taking the strategy plus the proxy plus the repository, you can get something like the cached repository pattern that you can inject and manage all your caching logic in one easy to manage way. All right, so I'm going to jump to questions in a second, but thank you very much for watching. And FYI, if you're looking for a new job, here's my plug for Telerik. We have a bunch of positions open at the moment, so check that out. With that, let me jump to Q&A and copy and paste the references into Jabber. Maybe. Yeah, sure, why not? You guys are so lazy, I love it. Where's Jabber? Jabber. Look at that. How easy was that? Alright, what else? When to use Memento. Memento, the best example I've used Memento for is to implement undo. So for instance, you're drawing you're making a paint program and you want to be able to undo multiple drawings of paint. Well, you can just keep a memento of each operation, which is basically a command, and then you know how to undo each of those operations. So you have a stack, and as you pop things off the stack, when they hit undo, you remove those things. I actually use that exact demo in the Pluralsight design pattern library when I talk about memento there. Let's say you inherit an existing EF data layer and it doesn't use repositories, but you want to. What's the least painful way to convert? I would do it on a case-by-case basis. You've got a particular controller or a particular class that is using Entity Framework directly. Implement a design pattern. Let's say that you have a particular thing you need. You don't need every method that Entity Framework gives you. You need a very narrow, thin slice of that. Like, I need to be able to select a customer based on their ID and update a customer. So create an interface that knows just about how to do those two things, and then implement that interface with the actual Entity Framework code. And then just inject your implementation, and now you've decoupled that one class from Entity Framework. Repeat that as often as you need to until your code is generally getting better and better. For wizard implementation, which pattern? I'm not sure. Do you use unit of work with repositories? Yes, you generally have to, but most of the most of the ORM tools out there have unit of work built in. So for instance, Entity Framework already has unit of work built in. So you probably don't need to implement your own unit of work pattern so much as your repositories might just have a commit method or something on them that then calls into the underlying Entity Framework save changes method to actually do the commit. Did that. What's the difference between command and domain event? Not sure. If you're talking about sort of a CQRS sort of event thing, I think they're very similar. But command is more of a specifically implementation detail of one particular action you want to do. If you do that across the board for every type of change that occurs in your domain, and you call those domain events, then yeah, those are just a whole lot of commands that it's a specific implementation of the command pattern that you're using in that case. What do you think about using interception for caching? I'd like to see an example. If you're talking about, again, like an AOP type thing, I think that's AOP can be great for cross-cutting concerns like that, but it can also add complexity. If you're not talking about AOP, which is aspect-oriented programming, then I'm not sure, without seeing some code, what exactly you mean in there. Is there a problem running HTTP runtime cache for repository caching? I associate HTTP with upper-level web apps. There's a whole bunch of different caching implementations. You can use HTTP runtime cache, it's fine. You can use HTTP runtime cache from a console app. The fact that it says HTTP runtime in it, or system web caching cache, or whichever, doesn't mean that you can't use it outside of a web environment. But in the latest versions of the .NET framework, they have actually pulled out all the cache stuff into a root system level namespace that you can use. In addition to that, there's other third-party cache implementations, or there's the caching application block that you can get. So there's a bazillion different cache implementations you can use. Let me make sure nobody's telling me to get out of this room yet, are they? All right. How are we doing on time for the next person? Who is next? 4:30, which is really 5:30, which is 18 minutes. Oh, I got lots of time. All right. Copy. Can we send a repository, for example, iCacheable in constructors? So in that case, if cacheable is null, then data is not cacheable with the null pattern. Certainly. Also, it's good to note that in the sample code that I have shown you here, I'm not necessarily decoupling things as much as I would in my real code. Let me show you what I mean. In the cached album repository, let's pretend that I have like 5 different methods here that all do database queries. I'm not going to do this work 5 different times inside this code. I'm going to actually have another interface called iCache, and iCache is going to do this work, and I'm just going to inject it in here. So at that point, my implementation of caching, in this case, this little hard-coded HTTP runtime cache, is going to be in the implementation of iCache. Now, I didn't show that here because it just adds a little bit more complexity than I want to get into in an already fairly complex example. But again, for real code, when you start to see that repetition, there's the don't repeat yourself principle, the dry principle. If you start seeing this same logic right here that says, here's my cache key, here's my if statements, blah, 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 that's definitely a candidate to pull that out into a separate interface, and then you can implement that with your cache provider of choice. I know that wasn't exactly the answer to your question here, but you made me think of it. Can you talk about visitor? Probably not in the time I have right now. How can I download this PowerPoint? Look for it on my blog soon. And let's go back to Jabber. Stupid toolbar gets in my way every time. There we go. A few more of these. Let's see. How does proxy differ from decorator? I think I covered that. That's basically just mainly the intent. Commands are acting like the NoSQL eventual consistency there to scale. Yeah, because, again, like using the Amazon example, if you are expecting that most of the time the checkouts will succeed, then it's perfectly fine for you to pass off those commands to get them done eventually, but let the user continue driving on. And yes, that's exactly like what you're talking about here. For factory, why did create instance take in a type? That's just an implementation detail for how I was doing that. How do you feel about generic factory? For instance, some type create some interface. Well, that's basically what an IOC container is. So to answer your specific question, my implementation detail here was that I need to be able to say that if the type, well, okay, in this case it's not important. But if I had multiple types, then I would have a switch statement in here, and it would say, I need a album dependency, or I might need, you know, in my MVC music store, I've got different types. I've got albums, I've got artists, so I might have a different one for artist. And so if my type that comes in here is artist, then I'm going to go into the artist creation block. And if it's for album, then I'm going to do the album creation block. The thing is that at this point I'd stripped out the if statement, so there's no real reason to have this here. But that's the original intent, is there's a switch here that would say based on which repository type, that's the different dependency you need. It's also true that sometimes you might need multiple dependencies on multiple different tables in order to pull this off, assuming you're using the table-based SQL cache dependency code here. And then your other question was the generic factory. Again, that's pretty much what the IOC container is. So that I can say to my IOC container here, I can tell it, you know, give me an iAlbum repository, give me an iStore repository, give me a whatever, a checkout controller. Doesn't matter what I ask it for, it knows how to do it, and it just pulls it all in through here. And it might do it all magically with something like this default conventions, or it might be that I had to hard code it, where I said specifically for that one type, I want you to use this one type. And that's totally up to me to do in this one place. And so this is nice because it's not violating single responsibility principle, because it's all right here and it's all in one place. This whole, architecture of my application is basically all described in this one little class. And I think, understood, thanks, great, awesome. I think I'm out of questions, out of time. Can we use func in structure map for lazy loading, for example, repositories, or is there another way? You can use func with structure map. I don't know about using, yeah, you can use it in structure map, sure. So for instance, in here, you can say for this use, so you can say something like x.for iAlbum repository dot use, and you can put in a func here, and you can say a such that a dot do some work here. So you can, if that's what you mean, yes, you can use a func right here to do whatever it is you need to do as part of this construction. The different IOC containers have different ways of doing that kind of thing. So I don't know if that answers your question, but I hope it does. Another thing I can mention real quick is, if you're not familiar with it, there's a great type in .NET called lazy of t. So it's like system.lazy operator. And what this will do, if you look it up and play with it, just do a Google for system.lazy, is it will let you do deferred execution on anything, or add lazy loading to anything in your code. So if you're not wanting to implement that yourself, check out system.lazy as an easy way for you to defer execution on things without having to go and create an actual factory that knows how to do it. You can just pass in a system.lazy, and now the code that's using it doesn't even know that it got a system.lazy necessarily, or maybe it does, it's up to how you write it. But it'll only actually call the code to instantiate that thing at the moment in time when it needs it, and only if it needs it. So, all right, I'm out of time and my voice is going, so I'm going to call it done. Again, look for me here on rdallas.com, which is my blog, and that's where I will be posting all of the slides and other goodies from this talk. It looks kind of like this. So thank you very much, and I'm going offline now.